Leetcode problem today, 1366, rank teams by votes. So let's try to understand the problem. Yeah, so we are having an array of votes. It's gonna be just letters. Yeah, but there is a sequence for the letters. If it is in the first place, for example, this A, so we're gonna always choose A. So because there are 5 voters choose A at the first place, so we're gonna choose A first. Yeah, but for this B and C, yeah, you see for this B there are 2 voters, and ranked third by 3 voters for this B. As you can see, there's a BB and CCC, but for C there are 3 voters. Yeah, Team C was ranked second by 3 voters and ranked third by 2 voters. So this means we're gonna always choose the most number of ranked if they are not equal. So we're gonna choose C first, and then we're gonna choose B. Yeah. So if everything is equal, we're gonna choose according to the increasing order of the alphabet. So basically, if everything is equal, we're gonna choose alphabetically. This is also inside the description. Yeah. You can see that if 2 or more teams are still tied after considering all positions, we rank them alphabetically based on their team ladder. Yeah, so this means if everything is the same, we're gonna always choose A first and then B and C. How can we design such kind of data structure for solving the problem? As we know, there is always an importance. For example, this ABC, at the first place, it is always important than the second place. For example, in the first case by team A, so inside it's gonna be a 5 0 0. So this means this is always the first place. But for the second one, for the B, it is 0, 2, and 3, and for the C, it is 0, 3, and 2. As you can see that we're gonna always sort this according to the decreasing order. It means 5 is the most, so we're gonna sort A as first, and then C, because this 3 is bigger than 2. Yeah, so we're gonna design some data structure like that. So A to 5 0 0, and B to 0 2 3, and C to 0 3 2. If we can design such a data structure normally, we can solve the problem. So if there are only 3 letters for each of the vote. Yeah, now let's try to design such data structure. So we're gonna use a dictionary. It's gonna be default dict, and inside I'm gonna use a lambda. So it would be, yeah, so in this lambda, no matter what key it is, but the value would always be 0 times n. So this n is just how many letters in each vote. So length of the votes 0. Now I'm gonna prepare this kind of a dictionary. Yeah. So for vote in votes, for IV in enumerate the each vote. Yeah, I will put it inside the dictionary. So the V with this letter, and I should plus equal to 1. Now let me print out the dictionary. Let's just recheck what it looks like. Yeah. Now let's just check the dictionary. As you can see, the dictionary is as ever expected. It is 5 0 0 0 2 3 and 0 3 2 for this letter C. Yeah. Now I think we can continue. I will put the p-value pairs inside the result array, because finally I'm gonna return some part of the result. Yeah. So the result array would be list d dot items. I will take out all the items. Then I can sort the result. I will use a lambda function because there is a lot of limitations. So for x1, I'm gonna sort it in reverse order. Yeah, but if everything for this x1, like for these numbers 5 0 0, maybe another one is also 5 0 0, if they are the same, I'm gonna check the letters. So the letters I will use odd because yeah, I need to use a minus value. It must be an integer. It is not a string. So I have to turn it into odd for x 0. So after sorting, I'm gonna return the result. So the result would be empty.joy. It should be yeah, k value pairs, k for kv in result. So because this k is just the letter. Yeah, now let me run it to tag. As you can see, it works. Now let me submit it to tag if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Now let's just have a check of the time complexity. So as you can see here, this is a 2 for loop. So it is the length of the vectors and the length of the string. Yeah, let's just check it. So it is like 1000 times 26. So that is for the time complexity from here. But for here, inside the result array, so there is a sorting. Yeah, so for the result array, so yeah, let's just check the d.items. So this is the dictionary, and there's 26 letters, and we're gonna sort it according to this string, according to this kind of tuples. Yeah, so this is difficult to calculate. So this is 26. After 26, we're gonna check the length. We're gonna check how many roots, and the roots is also 26. Yeah, so the length of the tuple here is also 26, but there is a sort. So we're gonna sort it according to the first place. For example, this one, it is 26 log 20 n log n log 26 times. Yeah, let me just calculate it because this sorting is a little bit difficult to calculate. Result.sort, it should be, first of all, our result array is basically about this a, including, yeah, basically it is 27 characters. Yeah, because including the length would be 27, because inside the tuple it is 26, and including this letter it is 27. Yeah. So we have 27 of them, and for each of them it would be 26 times log 26. Yeah, but there are 27 of them. Yeah, I think this is the time complexity for this. Yeah, yeah, let me just check. And for each of them, it would be 26 times log 26. But if they are equal for the next one, yeah, there will be another 26. Yeah, so this would be the time complexity for the sorting. Basically, it is n cubic, and 26 cubic is still a small number. So yeah, that's it. I think that's for the time complexity. Another one is we needed to compare which one is bigger, 1000 times 26. I think 1000 times 26 is bigger, or this one would be bigger, but basically the time complexity should be less than 10 to the power of 6. Thank you for watching. See you next time.